And welcome, Math 212. We are beginning Chapter 7. Chapter 7 is on statistics and probability. You will be working with your students on measures of central tendency. You'll be looking at graphs. You will be doing some probability with your students. So all of these things from 6th to 8th grade, you'll definitely be doing, and then a few things in kindergarten through 5, especially the analyzing of graphs. So these are the topics that we're going to cover in 7.1, and it's quite extensive, so let's get rolling. We're going to look at using statistics to answer our questions and collect data. So we have 4 basic components whenever we are trying to answer a question. The first thing we need to do is formulate a question, and we're going to need to figure out what it is that we need to ask somebody so that we can collect that data, so that we can kind of have a good idea. Now, one thing about statistics is it is very fuzzy. It's got a lot of gray areas, so there's not necessarily a clear right or wrong answer. It's just how can I best answer a particular question is what you're doing whenever you're looking at statistics, because I could ask all sorts of questions. What are the chances of you getting a job after you graduate? Well, there are all kinds of different factors that apply to that, such as your grade point average, where it is that you're going to look. Is it going to be in a big city? Is it going to be in a remote area? Exactly what was your core subject area? So we've got to collect some data, many different ways to do this, many different ways to get biased data whenever you do this as well, so you need to be thinking about that. We need to, you can do it by just watching people and seeing what happens. If let's say you're in the grocery store and you want to know something about what vegetable somebody goes to first, or do they go for a particular vegetable, or is it that they're going to the one that just happens to be first in line? All kinds of different factors affect things whenever you're looking at collecting data. Then we've got to compile this data, and then we've got to figure out what it all means. We've got to figure out a good way to put it in a graph. There's all kinds of different graphs to choose from, and all different ways to compile that data. So we're gonna look at several different ways to do that, and we're going to figure out how to interpret that data. Oh, and of course here comes interpretation next. So sometimes your data isn't numbers, but it's categories, and our categories would be something about what color shirt people are wearing, and those categories of data, something other than a number. Here is a nice question. How many siblings do you have? Seems like a simple question, but then again, we start talking about adopted siblings, half siblings, step, foster siblings. Somebody's not going to stay there for long. What about a sibling that doesn't live with me? Do I count it if someone died? All kinds of different, I guess, sidetracks that you could to that one seemingly simple question. With this as well, we might be looking at family dynamics, and we might want to know, well, how many siblings does your mom or dad have? Are your parents divorced? So does it matter if there's a stepfather or stepmother? Many different facets to a seemingly simple question. So let's say we did ask the question, and let's say this is the data that we collected. You can take that data and put it in what is called a frequency chart, and that's what you have here. This is a frequency chart. That means there are 3 zeros. So if I go through here and count them, 1, 2, 3, I would see that there are 3 zeros. There's going to be 6 ones, 4 twos, and I could put these in a pie chart, a histogram. You're going to see us do this later on in the lecture. Another thing you could do is a stem and leaf plot. This one doesn't really need stem and leaf plot, but we'll find some data that does here later on, and we'll do one of those as well. Now with this data, we can talk about mean, median, and mode. Those are all measures of center. And these are the definitions for our mean, median, and mode. Each one of these is considered an average or a measure of center, just because we're so accustomed to adding all of the numbers up and dividing by however many there are, which is the mean, does not mean that that is the only measure of center or the only average. And we have to figure out which measure of center makes the most amount of sense for what our question is. So here they list off mean, median, and mode and what those definitions are. So with our sibling data, we have a mean if I added them all together and divided them by however many there were. Looks like there were 19, so they added them all together, divided by 19, they got 2.47. And for the median, what they did was they lined them all up, and then they just take the exact physical middle numbers. So let me see if I can do that for you. Okay, I just drew a line here just to show you there's 9 on either side. They're all lined up in order. They must be lined up in order. And you pick the middle number, and there he is. He is a 2. If you have 2 middle numbers because you have an even number of data, you just add the 2 and divide by 2, and that's how you get the median. The mode is just whichever one occurs the most frequently, and you can see with our, where was it? We can see right here the mode is 6 because that's the one that occurred most frequently. I like the frequency chart for that. Just some generalizations here. If you're looking for the middle data value, then your answer is the median. That's the physical middle. Very common application of this is if you are looking to move to a new town, you want the average price of a new home, you usually look at the median. If you are looking for just a general average, as we might call it, you're looking for the mean. But now be forewarned that average is a word that is used for really any one of these measures of center. So be very careful when someone tells you that this is the average. They don't necessarily mean that it is the mean. So these are all 3 called measures of central tendency. This is what you are going to have your students be able to find, is any one of these measures of central tendency. In looking at this data, we can come up with a few different conclusions. The average number of siblings is 1, 2, or 2.47 because there's the mode, there's the median, and there is the mean. Any one of those, a newspaper or article or what have you, could tell you was the average, and they are not lying to you. So measure of central tendency does not necessarily mean add them up and divide by however many. Another conclusion you might have is that more than half the class had 2 or few siblings, and 2 students come from much larger families than the rest of the class. We would call those outliers. So we'll say they were outliers. And that means those that are way different than the rest. We're going to discuss each one of these in detail. First up is the mean. That's the one we typically think of. And exactly what is it when we say we're talking about the mean? And what does it tell us about the data? These are different questions that can be answered. Not necessarily is the mean considered the best measure of central tendency. You have to look at the whole picture, and somebody could easily say that either the mean, median, or the mode was the average or the exact measure of central tendency, and they wouldn't necessarily be wrong, but they might want to mislead you in some way, and they can easily do that because those definitions are all measures of central tendency. So if this is typically what we do when we are averaging your grades. So that's why people tend to think that average means the mean, but doesn't necessarily mean that. If you were wanting to get, let's see, the average height of all the students in your class, you might not use the mean. The outliers tend to affect the mean quite a bit. So if you're looking at average prices of homes or average height, you might want to use the median because the median tends to disregard those outliers that would affect the mean more. Sometimes the mode can be used as the average, but usually the mode is used when what you're looking at is not necessarily a number. And here we have a repeat of everything that we've been saying so far. Just that sometimes the mean, median, and mode are close and sometimes they aren't. So let's imagine that we have some school children and they were asked, how many movies have you seen in the past year? And then they give you those answers. You might want to represent those values in a bar graph. These bar graphs kind of give me a general idea of what the data looks like. Here are different representations of that. And you'll notice that the concept of mean is frustrating because mean and average are not necessarily the same thing. But something that we do know is that even though you tell your students that, they will forget that you told them that, and then after a few months, they go back to thinking that the mean and the average are the same thing. Even though we've told them that it is not the same, we call that the rubber band effect, and this average, mean, and mean definitely has that. Numerically speaking, we would say that the mean is like the balance point. It is the place where all the numbers kind of converge, and we can think of that as a center of gravity, really. Let's look at it in this sort of fashion. We can see that the mean, if we were talking about the number of movies people saw, would be a 6 because that balances the numbers out. A very cool experiment, we're going to discuss this one in quite a bit of detail, is asking students, how many peanuts can you hold in one hand? So how many can you get out of there? And there's a lot of variation to the number of peanuts that you can grab. There's even variation in what you do time and time again. Notice that the author of this said that they did it 5 times and got 32, 28, 22, 31, 35 peanuts. This is called measurement variation. And in data collection, you definitely have variation in your data collection. Some of the things that are going to affect your data collection might be how it is that you reached in and grabbed your peanuts. Did you just reach down there and grab as many as you possibly could, palm down, or did you just kind of lay your hand in, dig your hand in there, lay it palm up, and just whatever happened to get in your hand you grabbed? Well, we try to make things consistent in our data collection, so you kind of eliminate all of those variables that might affect. So we have everybody just reach in and grab it, because those variables that affect our data, we don't want those to occur. So here we've told everyone just reach in and grab your peanuts. And this is the number of peanuts that they got. We're going to look at some graphs of this data. Here we have it aligned, and we could see that it'd be easy to pick out the median for this. Looks like it'd be right around there at 25, doesn't it? All right, Here we have a line plot, and we just put X's over however many it is we got. I see that the mode for this would be a 22. If I line them all up, it's hard to see the median in this. I could definitely, let's see, they got it right here. The mean is 25.3, median's 25, and the mode is 22. So if I were to add all of those up and divide by however many, I would get 25.3. These guys right here, this, especially that guy right there, he really affects what the mean is. And if we were to eliminate that outlier, that would kind of help us in getting a better idea for what the mean is, because this guy right here who got 37, he affects the mean in making the mean greater than what really most of the data is represented here. Here we have a frequency chart, and in this frequency chart, somebody just selected to break this up into groups of 4, but you can break that up into 2s. You can, of course, do singles, but it just makes the data easier to look at. And this histogram is a histogram from this particular frequency chart. I could have made a different frequency chart, and I would have had a different picture for my histogram. Here's another frequency chart for the same number of data. Any one of those is correct. It's whatever it is, you know, I don't know what it is that we were necessarily looking for. There might be points that somebody who's collecting the data wants to try to make. And statistics is one of those fields where you can make your data appear however you want to just by rearranging things. If you will notice this right here, it is the least black and white field of mathematics. It's fuzzy math is what I like to call it. So it is very important that you understand that these measures of center can be misleading according to however it is you want to arrange the data, what picture you want to show, and what kind of graph you want to show it with, and what those scales are as well. Here's a summarization of mean, median, and mode, and why you would use those and why you wouldn't use one. All right, next we're going to look at some distributions, and we will see that these distributions are going to be graphed, and things are going to be skewed left, right, bimodal, modal, or uniform. So uniform graph makes sense. Skewed to the right, in order to remember this, I tend to want to think skinny to the right, because if you'll notice on the right, he's kind of skinny. So skinny to the right or skewed to the right means that most of my values occur to the left. Skewed or skinny to the left means that most of my values or my mean occurs to the right. Bimodal means you have 2 humps in it, and this is a normal curve. And in statistics, we study the normal curve extensively. Here's a histogram and a line plot, line graph, so that we can see what this looks like. Notice that my histogram and my line graph look very similar. And I can see, you know, that I have kind of looks like a normal. It is skewed just a little bit to the right, but not much. It is mostly fairly uniform. And it is, oops, let me just mention that it is these 2 guys right here that make it so that it doesn't look like a normal, because if I had those 2 guys out of there, it would look more like a normal curve, which is something that's important to us when we're studying statistics and collecting data. Here are different examples of each. Months in the year. Of course, that's uniform. Salaries in a factory. If I think about salaries in a factory, there's a lot of people that work in a factory. So the salaries tend to do like tend to be a little more like this. These would be those people in management, and these would be the factory workers, and it would be skewed to the right because these guys would make there just be fewer of these guys to make more money. If I was looking at that. And then class sizes in high school, they tend to be, the smaller classes tend not to make, so, but they don't mind for your classes to be big, but they do mind for your classes to be small, so they cancel those classes, so you would have your mean that was skewed more over there to the right, so it would be skewed to the left. Then bimodal, we have those that finish early, those finish late, tends to be bimodal. Normal, the heights of people, this would be heights of people, weights of people, IQ tests are normal tests. So many things are normals. Oh, here we are going through a slide that talks about the salaries in a factory, explaining to us why that would be skewed to the right. And if our data is skewed, we tend to use median as our measure of central tendency. If we have something other than numbers, then we use the mode. This symmetric distribution, the mean, median, and mode tend to be all close together. Variance is something that we also look at in statistics, and that is if I have a mean that has a small variance, that means that most all of my data is centered towards the mean. If I have a set of data that has a large variance, that means I have my mean, and then all of my different data points are really fairly spread out away from that mean in a larger number. Teaching students to look at these graphs and analyze these graphs is basically a life skill that helps them to not be swayed by somebody that's trying to manipulate what they're thinking by the graph, but teaches them to look at the graph and analyze the graph and think about maybe who it is that's trying to present us with this data and trying to show us a particular point of view or point of thought. So when we're looking at graphs, we need to think about 4 things. What can I conclude from the graph? And then the construction of the graph itself. Did somebody try to mislead me by changing the scale? Should they have used a different graph? Who obtained this data? If I asked you some question about studying for the test, if I asked it, you would tend to tell me that you studied maybe a little more than if you were talking to a fellow classmate. So it depends on who's asking the questions as well. So that would be the reliability and validity of that exam. And then, are there further questions that we could ask to get a better idea of what's going on? This is the percent of fatal accidents involving alcohol. All kinds of different questions that I could ask from this one particular question. Were they car accidents? Were they motorcycle accidents? Fatal accident, does that mean just somebody who was, say, out shooting a gun and had been drinking? It doesn't necessarily mean a motor vehicle accident, does it? It could be a bicycle accident, could be a horse riding accident, could just be an accident where somebody fell down or off a banister. Up hitting the books. This is a question where we have a graph and we can look at it and we go, well, when someone asked that question, were there only 3 options? Or were you allowed to give a numerical answer? Because just because they presented the graph in this way doesn't mean that that's how the question was asked. And who was asking the question? And where did they ask the question? Did they ask it in the library? Did they ask it in a bar? Where did they ask these questions? That would also be pertinent to what this graph ends up looking like. All right, that concludes our 7.1, and good luck. And if you have any questions or if you need anything extended, always be sure and let me know, because I know that some of these questions are longer than the others. So if you need any extra time, feel free to email me and ask me for that. All right, and y'all have a wonderful day.